G'day, today we're going to be looking at properties of circles, and in your textbook there's a number of them listed. I've also attached another video for you to have a look at, which is just another way of getting information. So anyway, going through these properties, angle of the semicircle, we know it's 90 degrees, and I'm not going to talk all the way through them, but these properties you need to know and you'll need to better use. Alright, so if you're going through those, they're really important, all those properties. Now what we're going to do is have a go at proving some of them, which I think is probably a pretty useful thing to do. So if we look at this first one, we've got basically A and B, and we have to prove that this angle here, ABC, is 90 degrees. Right. So if we know that these are isosceles triangles, then we know that obviously each of these particular sides over here are going to be radii of a circle. So we know this is the radius of a circle, so we know all of these sides here are all basically R. Right. So therefore, if we know anything about isosceles triangles, we know that the angle there A and that angle there is B. Right, we know that's the case. Now, the other thing that we know with this particular thing here, the sum of the interior angles equals the exterior angle, and so therefore that's A and A, then this here must be 2A, and again B and B means that this must be 2B. Alright, so this is our thinking. That we haven't recorded anything yet, but this is our thinking. So we would need to say something about that. We'd need to say that angle, do this one here, angle BOC equals 2A sum of interior equals exterior angle. Right, so you need to say something like that. Now we know that in a triangle that 2A plus 2B has to be equal 180 degrees, and that's basically triangle equals 180 degrees, and so therefore A plus B has to be equal to 90 degrees, so therefore angle ABC equals 90 degrees. Alright, so therefore that's the little proof that we need to do for that first one. In question 2, you've got obviously a line going from P to and cutting at A and B as tangents. Alright, so we need to join the line OP. Alright, so that's what it's saying, is join that line there, join these lines here, and join that line there. It's sort of giving us a bit of help with how to do the proof. Assuming that the tangents, we need to prove that triangles POA and POB are congruent. So if we do that, we know it's a right angle. We know that's a right angle. Alright, so we'd say angle, right, PAO equals angle PBO equals 90 degrees, and so therefore, because we know it's a tangent. Alright, so we have to give it a proof why it is. We know that basically angle OA, or not angle, but length of OA is equal to OB. Alright, and that's equal to the radius of the circle. Alright, so that's what we've got there. And we know that OP is common to both triangles. Right, so that's what we do know there. So if that's true, then we can say that triangle POA equals triangle POB as RHS. because they have a right angle, they have a corresponding side and have the hypotenuse. OP is in fact the hypotenuse, so therefore congruent. Now, the last part of this tells you what's the consequences of the congruency in part B. Well, if that's congruent, that means that the following sides means that this particular side, OA, AP, and BP have to be equal. So that's what the proof actually tells you about those particular triangles here. Alright, going down to the third one. In this question, we establish the angles of the centre of the theorem, the centre of the circle theorem, explaining why triangles OP must be isosceles. Alright, so OPA and OPB have to be isosceles. So therefore, again, if we're considering the same sort of things that we just talked about in the previous question, these are in fact isosceles triangles. Therefore, that's A. Therefore, that's B. Isn't it? Alright, so if we've got, obviously those particular things, obviously it's the radius that determines whether these are isosceles triangles. So that, anyway, we've proven that bit there. Let's go down to part B. Find the measure of the following angles in terms of A and B. So the first one, APO. So APO is going to be equal to A. BPO is going to be equal to B. Right? AOX, we have to work out what that's going to be. Now, what do we know about that? The sum of the interior angles equals the sum of the interior angles is equal to the exterior angle, so that's going to be equal to 2 lots of A, which is there. Alright? BOX, again the same excuse or the same reason, is going to be, that's going to be not 2A but 2B. APB, well, we know that's going to be A plus B, and we know then OAX is going to be 2A plus 2B, which is equal to 2 lots of A plus B. In other words, what we're proving here is this angle here is twice the angle there, by just using those properties. Alright, so again, we're just using our triangular properties to prove our circle theorems. Alright, so anyway, if you watch the other video I've attached to your particular program, it goes through some more of these proofs and the 9 key things that you need to know about circles. We will be working through some of these in class, so make sure that you continue on with these exercises.